Hello friends and welcome at my channel. Today I would like to show you how to visualize the derivative of x squared and the product rule. So let's start. If we're talking about the derivative of x squared, I hope you're familiar with the result. The outcome is, so if we have f prime of x, that would be just 2x, right? So how can we geometrically visualize it? Well, let's pretend we have a square with the area of x squared with the side length of x. So the basic idea of the derivative is we have an increase of the area, but just tiny bit prolonging the side length here, which we call dx, differential x, which is a tiny bit small number, and the same amount here, dx. So the whole gain of the area would be right here, and we got infinitely small numbers dx, tiny. So you can imagine it like you have 1000 meters, which is the length of x, and dx would be 0.1 meter, for example. So this is a good comparison maybe. And so what is the whole increase, kind of the red area? Well, you see, we have the corner here, which is the product of two infinitely small numbers. So this is dx times dx. Since it is so small, we can assume, so the product of two infinitely small numbers, so kind of infinitely small numbers squared, we can assume it's almost zero. So we actually can forget about this. So the whole increase is this area, which is the product of x, which is the width, times dx, which is the height, and the same is also here. We have x times dx. So the total increase would be x dx doubled. So you see, if we're talking about the infinite small amount of the area which has increased, this increase would be 2x, which is the result of the derivative, for example, by the first principle. The second example that I want to show is the product rule. As you're familiar, guys, u times v. I don't know why we use these letters everywhere in the world, because they're so actually easy to misspell or to misuse, but it's all right. So we have u prime times v plus u times v prime, or as I would say, if we're talking about f of x and g of x, and we got a product, the product would be f prime of x times g times plus f of x times g prime. Why do we have to use it at all? Well, if you remember, there is a sum rule. If you have a sum rule like x squared plus x, you can separate it, you can prove it, you should prove it. This is the derivative of x squared plus the derivative of x, which is 2x plus 1. But if, for example, you are looking for the derivative of x squared, which we know is 2x, and you write it as x times x and just kind of forgetting that maybe a product rule or something, you say, well, maybe I'm just going to derive x twice, then you're going to have 1 times 1, which is 1. So it isn't working this way, obviously. So what went wrong? Well, this step is all right, but right here it went wrong. So how can we visualize this kind of formula? Well, you see, this would be f of x. The idea is the same, actually. And this is g of x. So the area is this rectangle, f times g. So we just increase the area by a small amount, which is df, and a tiny small amount here, which is dg. So the total increase would be this area. And once again, this corner right here is the product of two infinitely small numbers. So this is dg times df. So we assume it is almost zero. So we forget about it. What about this one? Well, this is f times dg. And this one is g times df. So this is the total increase, as you can see. So as you can see, the derivative of g times f unchanged plus g times f derivative. This is the product rule. I hope you got it. Have a good day, guys, and see you in my next videos. Bye-bye.